Today we're going to be talking about soil restoration and sustainability, and thank you all for joining us. We have three speakers today that are going to present some of their work, and we have Charlene Williams. Charlene is from Vinelad Research and Innovation. She's a senior research technician in environmental horticulture at Vinelad Research and Innovation Center. She has a master's in forest conservation from the University of Toronto and worked for the Canadian Forestry Service prior to joining Vinelad in August of 2019. As part of Vinelad's plant responses and the environment program, she collaborates with members from across the urban tree value chain, designing, developing, and implementing research to support evidence-based decision-making and best practices for tree planting, establishment, and maintenance in the field. She is additionally involved in both research and operations related to Vinelad's newly launched Greening the Landscape Research Consortium, where she leads case study research related to canopy climate readiness and grow contracts. Nicole North is from Walker Environmental. Nicole has spent her entire career starting in the early 1990s in horticulture. Her experience includes landscape architecture, nursery garden center management, entrepreneur and business ownership, and currently technical sales specialist growing media at Walker. Nicole has an honors degree in environmental science, horticulture and natural resource management from the University of Guelph. And we also have Mike Barbetta. Mike, you want to?
Thanks, David. I'm Mike Barbetta. I'm an area forester with York Region Forestry. I graduated U of T's Masters of Forest Conservation program in 2017, where afterwards I worked a couple years in the private sector as an arborist and plant health technician before taking up my current role with the region in late 2019. And in my role, I facilitate roadside tree planting and soil improvement work. I'm an ISA certified arborist and an RPF in training as a provisional member of the OPFA. Thanks.
Great. So just to let everybody know that's joining us, we want to save questions and answers to the end, but if you have something relevant within the talk, then please just post your questions in the chat and we'll be monitoring the chat as we proceed. So if you guys are ready to go, we'll give the, I can't say floor, I guess I give the mic to you.
There we go. So everybody can see this is an overhead view of the main one of our facilities that we work at here at Growbar. This is our Caledon facility, and a little bit deceiving on the size of the property. What we actually have here is 65 acres of all of the materials that we use. A good chunk of the materials that we actually have here are materials that we make, but we also bring in other materials that are things that we don't make ourselves. But you can see there's a lot of bark and compost there, which is stuff that Growbar and Walker Environmental are known for. So one of the things that Charlene and I work together with quite often is, how do we fix a site? How do we make it work? And I am a biology, soil, and plant geek, and I live and breathe this stuff, but not everybody is. And I thought that it would be a good idea before Charlene does the part that we work on a daily basis to take everybody back maybe to first year university to soil science. And I love this, but you know, it can get a little bit boring, so I'll try to make it interesting. But you can see, you know, a nice picture on the left there of a typical soil profile. You've got your O, A, B, C, and R layers. The ones that we really care about the most, where the plants honestly are living and thriving, is your O and A layers. And some of the main feeder roots will get down to B. And the nice picture on the right is one that we've taken when we were excavating a site to see what we actually would find. And it looks pretty good. What people don't realize is that O layer that's actually at the top really only constitutes at tops 8 inches. So if you can think about excavating a huge hole where the majority of the plants are going to be living, and the important part is in the top 8 inches. If somebody is scraping that off with a loader for a subdivision, where does it go? What happens to it? So when we start getting into sites, this is what we normally find. We don't find that beautiful picture that we saw before. This isn't always this, you know, but we find in a lot of cases, like the photo on the left, where it's a lot of backfill. They brought in some fancy topsoil that's come off a farmer's field, or heaven knows where it came from, and it's organic. Yeah, I love that word, organic. What does organic mean? So and in the worst case scenarios, we find what is in the picture on the right, which is rubble. And how do we fix that and make it better? So taking it back one step even further, all soils in the urban environment need 4 things: air, water, organic matter, and mineral matter. There are only 2 of those things in there that we actually blend together to make soil. So the mineral matter that everybody knows as the sand, silt, and clay, what does it feel like when you rub it between your fingers? What does it do? How fast does the water flow through? And your organic matter. Those 2 things combined 50% will end up making your air and water percentages in that soil. And depending upon how we mix them together, will constitute that soil's environment. So I'm sure all of you have seen one of these before, the soil texture triangle. It's taped on the side of my desk. I live and breathe this thing, and everybody always specs that they want to be in that perfect sweet spot where the loam sits, the right amount of sand, silt, and clay. Nobody ever stops to ask whether that's actually realistic in nature and how often does that naturally occur. Most environments, when we're looking at them, actually are a clay loam or a sandy loam. And that doesn't make them bad. It just makes them what they are. And how do we make sure that the plants that we're putting into that work and work well? So you can see I've put up 3 sizes there, of which 3 different particle sizes. And most people will always say, well, I can see sand. Of course you can. Sand is the largest particle size. You drop down 1 size to silt and even smaller to clay. Now, everybody always says clay is not our friend. Clay is our friend, actually, in smaller quantities. So looking at those 3 sizes with the little really bad diagrams that I put up on the picture of me scribbling on a napkin, if you think about putting those together, if you have 2 big pieces that are together, what can hold between it? Obviously things that are big. So the bigger the particles that we have create what are called macropores. Let's try that again. So those are your air spaces. If we start filling that up with smaller bits into the silt and clay, we start losing air and we start gaining water. Those things are all important about how we put them together. The reason why people don't like large amounts of clay is because what you get is lots of water holding and not enough air. So if you think about the next slide that I've got, you can see what happens down the chain when we start off with gravel, and then we go all the way down to clay, what ends up happening. Now, I'm sure I remember a professor that I had a long time ago who took a jar and filled it with golf balls and said, there's no more room in this jar for anything else, and promptly poured sand into it. Well, the sand filtered between. Is there room for anything else in here? We all said no. And he promptly opened up a beer and poured it into the top of the jar, to which we all cried, that's a waste of a beer. But the point of his story was that there was still more room for it to go in. So if you start mixing and matching all of these sizes together, what do you get? And how does it come out? And that's the world that Charlene and I play in all the time, of how do we mix and match all of these pieces together in order to make sure that the plant species that we're putting in will not just live, but will do well. So I put this slide in for something that everybody needs to really think about, because it is one of the most important things that we think about all the time is, of course, we need water holding capacity. Yes, it's really great. It is secondary to making sure that there is air present. So you can have a plant that will struggle as long as there is air present, but it will die if it is swamped because it's holding too much water in the soil. So all of those things are correlated heavily between how we put them together. Having said that, this is our sweet spot. This is our gold. This is what we're always looking for, is organic matter, that top little 8 inches of what makes everything the best. If you go into a forest and you are looking at how the system naturally survives, there isn't anybody in there with a leaf blower to blow the leaf litter out. It degrades on the forest floor and it becomes the organic matter. So as organic matter degrades, it becomes smaller and smaller particles, but it also releases natural nitrogen, phosphorus, and potassium slowly to the system. That's natural fertilizer in the environment. Natural systems don't add it, it adds it itself. As you can see with my bottom statement though, the smaller the particles get, the more that it bogs the system down. That little bunch of organic matter that I've got in my hand there will hold 10 times its weight in water. So if you think about, you only have to add this much to get this much, and you can't see my screen, with this much effect of what it will actually do if we are properly treating the soil. So one of the biggest things that I fight with is this. The pile of topsoil that has been excavated off a subdivision. I'm not going to tell you what subdivision this is because I could drive around where this Caledon yard is and I'd find 15 of them. Where's my O layer? Where's my A and B layer? They're all mixed up in that hodgepodge of mess. Did anyone stop to take a look at whether that soil was okay to begin with to plant in? Did anyone do a soil test? Did anyone see whether it could even be kept? Nope, it was chucked into a pile. So when you mix up all of those layers together, the system becomes inefficient. And you can't take that soil and make it behave the way that it was before. So all of those microorganisms and macroorganisms that are in that top O layer will die in that pile, which is why we now come to this. So the new legislation came into place in 2019. And I know there have been seminars that have gone on about this. And we were involved in helping to create this framework. And I am a very large advocate for this. It was helped to make the system better. It was Wild West. People would take stuff from all over the place and just dump it to get out of the way so that they could put in a new soil. Regardless of what the soil is that's in that place, it already exists in that flora environment there. The better option is always to reuse the soil on site. So this process, and I know there have been a bunch of the testings and the new parameters that have been put on hold until the beginning of 2023. But this new process will help us to be able to reuse the soil on site and make for a better management of what is being done and when. So now that everything has to be tracked, I mean, this is it in a nutshell. The document is huge and I put it down in 5 points, but what it's going to do, so anybody, it needs to start before you start your project. Where is the soil coming from? Where is it going to? And does that person agree to take the soil to the site that it's going to? And what has it been used for? If you are talking about a farmer's field and they say, oh, we only grew corn on it, that should be 10 red flags going up in your head of all of the atrazine that's been used to grow on that cornfield, unless it was an organic farm. So there are a lot of things that people don't necessarily ask that they should. And part of that is figuring out what the soil is and whether it is quote unquote contaminated, that it can't be used. And now that's going to be few and far between. So Charlene knows where I stand and we deal with this stuff all of the time of use what you have. Because I guarantee you, if you get the soil tested and you send it to me, I will probably tell you that there's either not much wrong with it, or that there is going to be some amendments that we could add to the soil in order to make it do what you are hoping for it to do with the plant list that you've got.
If it sounds okay, then I can just jump in because I'm going to take over right where Nicole left off and sort of continue the conversation as it relates to the research that we do here at Vinelad Research and Innovation Center. So as David mentioned earlier, my name is Charlene. I'm a senior research technician for environmental horticulture at Vinelad Research and Innovation Center, which is based in Lincoln, Ontario. Before I delve into talking about some of the research related to soil and the sustainable management of soil in the landscape, I'll just take a quick moment to tell you a little bit about who we are at Vinelad and what it is that we do. So for those of you who aren't familiar, Vinelad is an independent, not-for-profit organization that's dedicated to horticulture, science, and innovation. Our purpose and mission is to improve the economic viability, sustainability, and competitiveness of horticulture in Canada, where we work closely with industry partners from across the country to design, develop, and deliver innovative products, tools, and resources that set them up for success. Vineland's research is centered around 5 research programs ranging from automation, biological control, plant variety development, and consumer and market insights. I am part of the Plant Responses and Environment program, and our research is centered around building evidence-based tools and resources to support best planning, planting, management, and maintenance practices for trees in urban landscapes. The Plant Responses and Environment program has been part of Vineland's innovation and research portfolio for the last 10 years. And in that time, we've had the opportunity not just to conduct research, but to really collaborate, interact with, and learn from our partners on the ground, which include my two co-presenters this afternoon, as well as everyone from landscape architects, soil suppliers, urban foresters, landscape contractors, and nursery growers who come to us and work together with us to build the knowledge and evidence that they need to support the work that they do in the field, particularly given the range of challenges that they face in the landscape. These challenges are ones that we're unfortunately becoming increasingly familiar with, especially given what it is that we do. And Nicole outlined some of these challenges related specifically to soil, things like sourcing and the management of landscape materials, regulations limiting the movement of soil, soil scarcity, and the limited access to certain amendments on the market. And all of this really works to demonstrate the importance and value of sustainable soil management. So even though our research program is centered around trees, most of what we do in terms of sampling, analysis, and knowledge development starts with soil, where soil is quite literally the foundation into which trees, and any plants for that matter, establish and grow over time. So what I'm hoping to do today is just highlight some of the key projects that we've done in the last couple of years and give you a sense just of the range of research that we do related to soil. More specifically, I'd like to share some of our research as it relates to the concept of soil remediation. That is assessing the status of existing on-site soil and actively working to improve its physical, chemical, biological, and hydrological function through the implementation of soil restoration, which may include, like Nicole said, the addition of amendments or mechanical treatments to the soil, as well as the implementation of soil health best practices over the course of, landscape use and landscape maintenance. So one of our earliest research projects, which ran from 2014 to 2019, was the highway roadside planting trial, which really demonstrates the impact soil restoration and soil remediation can have on the productivity and growth of vegetation above ground. Essentially, this project was conducted in collaboration with the Ontario Ministry of Transportation, who were looking to identify and define strategies for improving tree establishment and survival across their highway roadside plantings. The trial started out by collecting baseline soil samples that were used to characterize soil conditions, evaluating key soil parameters that spoke to the soil's physical, chemical, biological, and hydrological function. By starting from the ground up, we were able to identify that the soil was really the limiting factor that was inhibiting successful tree growth and establishment on these planting sites. Where, as you can imagine, in general, highway roadside soils were extremely compacted with low organic matter, limited nutrition for trees and other vegetation, and also had extremely poor drainage. With this in mind, we designed 5 treatments related to soil restoration and implemented them in real highway roadside plantings, following up every year for 5 years to see how various soil restoration practices impacted tree survival and establishment over time. And so to give you a sense of what I'm referring to here, I'm just going to share my screen, which has pretty useful visual as to the results of this research that I'm referring to. So the results of this trial are shown here on the screen, and you can see in the photo one of our trial trees. In this case, it was an Acer freemani or the autumn blaze Freeman maple, corresponding to each one of our 5 treatments. So starting on the very far left, you have the control tree, where trees were planted without any kind of soil remediation into a standard planting hole. And as you move toward the right, you see soil remediation that consisted of deep ripping without any amendments, so without any addition of compost. And then you have deep ripping with 10%, 25%, and 50% volume to volume compost additions. And the results are pretty well demonstrated in the trees looking at them, just at the photos. where the findings from this trial showed that restoration with a moderate amount of compost, which was the 25% volume to volume, improved tree growth and establishment over the course of that 5-year monitoring period. And these findings that were not only used to recommend methods for soil restoration and planting, but they were also used to produce soil specifications that are tailored toward improving the success of highway roadside plantings here in Southern Ontario. I'm going to stop sharing my screen so I can see you all again. Perfect. Okay, so since the end of that trial, we worked with a lot of municipalities throughout the Greater Toronto and Niagara regions, building soil specifications to support more soil restoration and landscape planting projects, but also to really expand our understanding and kind of start to adjust our mindset with respect to the function of soil in the landscape. For the highway roadside planting trial, we approach soil as a growing medium, which of course it is. And actually, recently our team led the review and development of Section 5 of the Canadian Landscape Standard, which will be the new standard for growing medium that's set to be released, I think, early next year. So if someone could remind me toward the end of this talk, I can share a link to register for a webinar that we're going to be hosting, which is all about the new Section 5, and we'll be talking to a panel of experts about the entire review, development, and implementation process. So I'll try and remember to do that before we all sign off today. So getting back to what I'm talking about. So yes, for the highway roadside planting trial, we approached soil as a growing medium, but more recently we've started to address the use and application of soil in low impact development, where there's this huge potential for soil remediation and management to support not only the growth and productivity of trees and other vegetation, but to further function as a key component of stormwater management. So in the past couple of years, we've witnessed the impacts of climate change. We've all experienced it in our landscapes with record rainfalls and precipitation leading to widespread flooding that affects our homes and our public spaces. And at the moment, we're really working to start to use soil to start to alleviate some of that pressure, where we're working with a local municipality to design the landscape for a new development and a new public park, where they'll be utilizing soil to absorb and capture stormwater, not just to minimize the occurrence of runoff or flooding, but to make use of that water to support the growth and productivity of things like trees. So over the last 2 years, we've collected over 300 soil samples from these 2 sites that we're working on, evaluating again the physical, chemical, biological, and hydrological function of existing on-site soil, so that we can start to understand how we can strategically amend and remediate that soil so that it infiltrates and stores water. Although this project is still ongoing, we've already been able to demonstrate sufficient infiltration and storage at these sites through soil remediation that we've been able to eliminate the need for a stormwater pond at the new development site, as well as a swale at the public park, which, as you all know, opens up that space for different land use applications. As I mentioned, this project is ongoing and has currently entered a really cool phase of our research project, which I'm looking forward to telling you about. As with much of our research, we typically start analysis in the lab, where we collect soil samples from the field and work to replicate real-world conditions by building and testing model systems in benchtop experiments. The next step of any research project for us, once we've analyzed results and established our findings, is to apply and monitor those findings in the real world. And Mike Barbetta, who will be taking over the talk from me in a couple of minutes, will speak to some of the research that our teams have worked on together and how those findings have been implemented in York Region's planting projects. But before we get to that, I want to take a couple of moments to tell you a little bit about a new phase that we've added to our research process as of this year, which is basically an outdoor, full-scale experimental research park, which was here on the Vinelad Research Campus this past summer. So to give you a sense of what I'm talking about before I delve into some of the details about the research park, I'm going to show you a quick video that we put together. So again, I'm just going to take a moment here to share my screen. And I'll just play the video. There is no audio, so see if I can get it to play. There we go. And so this video is just to give you a sense of what I'm referring to when I say tree culture research park. I'm being completely honest, it's also a great opportunity for me to showcase some of my very basic drone skills that I was able to build this past summer as the research park was being built. But what you're looking at here is really the construction process for our prototype, which is 36 tree compartments. And so when I say compartments, as we're looking at the video, you can see these big white boxes. Each box measures 4.5 meters by 4.5 meters and then 1 meter deep. And basically they've been designed specifically for us to test the soil mixtures that Nicole was referencing and that I referenced a little bit earlier as well, with respect to some of our past research in a more controlled environment, or what we would call a semi-controlled environment. So this past summer, we sort of cleared the site. We were able to prep the subsoil and then install these tree research compartments. And this is the process of, installing the soil mixtures into the soil. And this is the finished product. This is what they look like right now. A little bit of an overhead to give you a sense of what they look like before I talk about them in a little bit more detail. I'm just going to stop there. The end of this video is just the team sort of taking a moment to appreciate all the hard work they put in over the summer. Right, so I'm going to stop my share, go back to our screen where I can see everybody. Perfect, so the video really showcased what we're calling our tree culture research park, and it is the first of its kind in Canada. It's a state-of-the-art facility that was specifically designed by our team to give us the ability to study trees and soil under semi-controlled conditions. So most research involving trees takes place either in the lab, like I said, where we have to work to replicate real-world conditions by building and testing model systems, or in the field where conditions can be quite unpredictable. So the Tree Culture Research Park offers us the best of both, where it allows scientists to conduct research trials and experiments at scale while controlling inputs and testing specific soil treatments under natural environmental conditions. Each tree in our Tree Culture Research Park is planted into a specifically designed tree compartment that's buried underground, as you saw. Tree compartments are essentially large containers that are filled with specific soil mixtures that are being trialed and tested either concurrently or prior to use in real-world applications. Like I said, the compartments measure 4.5 by 4.5 meters wide and then 1 meter deep, giving the tree roots plenty of space to extend and grow. And all compartments are outfitted with soil sensors, which measure everything from soil temperature, moisture, and pH to oxygen content, which speaks to that air component that Nicole referenced, as well as water availability, which speaks to the water component that she referenced as well. What's really cool, particularly for me with a background in sort of data modeling and analysis, is that the sensors are collecting data continuously and transfer that information to the cloud where it's monitored and analyzed by our research team. So far, we have 36 compartments that are fully operational, and these represent phase 1 of our tree culture research project, which will eventually include a total of 80 compartments when it's fully complete. And like I said, the compartments are currently being used to test soil mixtures that have been designed to capture and store stormwater in urban environments as part of a low impact development approach, which seeks to use stormwater to help support trees in the landscape. And so with that, I'm actually going to pass things over to Mike, who's going to speak a little bit to sort of the implementation side of some of the research that Vinelad was able to do over the past couple of years with York Region.
So I prepared a presentation to discuss the partnership with Vinelad that York Region recently conducted in regards to our soil improvement program, and also talk about some York Region practices in my experience working on those. Introduce myself, just to add on what I said previously. I've been an area forester with the region for about 3 years now, and one of my major responsibilities is what we call the soil trenching contract. And that's boulevard soil replacement or boulevard soil amendments to kind of improve the roadside soils we're dealing with. And as an urban forester for the region, that's the really compacted salty soils in the post-development landscape where subdivisions have just come up and who knows what they've left you. So a big variable in improving our tree establishment practices is to address the soils component. But it's a pretty tricky, complicated process, and there's a heavy-handed way of doing it, which is our soil trenching, and then hopefully over time find a more efficient, cost-effective way of doing it. And that's what the Vinelad partnership speaks to. So when I arrived at the region in 2019, the region was in the midst of a partnership with Vinelad that spanned about 2.5 years. And the intent of this partnership was to utilize some of the soil quality research and data that Vinelad had generated and use it to inform and improve York Region's soil improvement work. And two big components of this project was to review our soil mix specification and find improvements, and also to develop a new amendment specification for utilizing soils in place rather than replacing soils with our engineered growing mix. So just to speak to the EGM specification component, when I arrived at the region, we kind of had a complicated overwritten spec that was inaccurate in some ways, contained some incorrect information, some unrealistic asks, and just needed some tidying up and updating that was more evidence-based and backed by research. So part of what Vinelad did for us was go through kind of line by line, component by component, and really make some specific recommendations and provide rationale for those recommendations to back up and justify some adjustments to our spec. And these recommendations were based on both, improving providing an optimal growing media for the region, and also to address some practical supply chain related considerations, because some of the stuff we were asking for just wasn't realistic. For example, we had a big emphasis on low pH components. We were asking for sand that was below 7 pH, which suppliers were having a lot of trouble meeting. So we made adjustments to make our spec more achievable. Same with yard waste compost. It's higher in pH. We were asking for it to be below 7. And then other components such as topsoil salinity, where we kind of insisted that the electrical conductivity be pretty low, but there's benefits to having some electrical conductivity because it represents the existence of beneficial minerals and cations, sorry. So all those tweaks were made, and at the end of the day, we ended up with a more compact, informed mix that worked well for us and was more achievable by suppliers to provide us. And it's that characteristic kind of high sand, low clay attitude. And that's what we're currently using as our engineered growing media mix. Another key observation made in this report is that in the environment we were working with, it's graded sodded boulevards. So while in our spec, we did ask for low proctor density installation, in practice, that's not really possible to maintain when we're having to restore the boulevard to an even grade that pedestrians can walk on, vehicles can drive on, and so on and so forth. So while we are asking for a low density installation, in practice, we were going to end up with compacted soils one way or another. So just some photos of some soil replacement work in a grass median. We can go in and add the mix all we want, but at the end of the day, we are grading the mix and sodding it and restoring it to pre-existing conditions. So while we do want to address some of the compaction on our boulevard soils, at the end of the day, we're going to be working with compacted soils. It's just kind of a fact of life for the site conditions we're dealing with. So with this in mind, Vinelad worked out a laboratory experiment where they explored the relationship between highly compacted soils and some relevant variables that we could control. If we can't always control compaction, we can control what we're putting in the soil. And these variables with sand percentage and the organic matter percentage of soils, and see how they relate to soil characteristics that are important or critical for tree growth. And the results of these experiments indicated that increasing the organic matter content of soil also increases the soil's ability to resist compaction as it relates to adequate porosity for root growth. And that there's a relationship between the organic matter components and the sand component. So both organic matter and sand can play a role in having compacted soils that are a little bit suitable for tree growth. And part of the experiments that are contained in this report, and this is just a snippet that I'll do my best to explain. This is showing 3 different soils compacted to 90 to 95% crop density of different textures of sand and different organic matter percentage components. And what you're looking at on the y-axis is both the volumetric water content and the porosity. The circle represents the water content at field capacity, and the square represents the total soil porosity. And the larger the gap between the circle and the square shows that there is leftover pore space in the soil for air when soil is at field water capacity. And the red dashed line represents the 10% range where roots would have access to water, but would have insufficient access to air to allow for root growth. So ideally what you want is for there not to be overlap between the square and the red dashed line. And you can see in the lower sand component soils that are highly compacted, you run into that issue where if it's low sand component and it's compacted, the roots aren't going to have enough air to facilitate proper root growth. But once you start getting into mixes where there's a little more sand and importantly more organic matter, then even though there's some compaction, you can still have that adequate porosity to allow for root growth. And there almost seems to be a sweet spot with texture and organic matter where you can take a heavy-handed approach and insist on a very high sand mix, or you can realize that if you can just increase the organic matter content of the soil, maybe you can go ahead and start addressing these issues. So in my mind, what we have on the right kind of represents our approach with our engineered growing media. We can take out the pre-existing soil and introduce a high sand mix. As an alternative to soil replacement with a high sand component, we can just find a way to incorporate organic matter into the soil. And then we don't necessarily need to dramatically change the texture on site. And this lends into the idea of, a viable evidence-based mechanism demonstrated through this experiment that supports the merits of an amendment trial instead of just replacing all the soil on site. And with this in mind, Vinelad also developed a organic matter amendment treatment that we could utilize in our boulevards. And we still have to remove some soil because we have to restore that established even grade with the surrounding landscape. But instead of removing, 50 centimeter depth, which is what we typically do with EGM, it's just the first few centimeters, and we apply an amendment of 60% high lignin organic matter and yard waste compost. And then we incorporate that organic matter into the pre-existing soils on sites. And this was implemented in a trial that we installed in 2019. It was set up as a scientific trial adjacent to our traditional EGM trenches to allow for a comparison between the 2 treatments. And we've installed a few more organic matter trenches as well. And the next steps will be to monitor these sites for soil quality and tree performance and continue to modify our practices based on these findings. So the current approach currently consists of doing a site evaluation, looking at some topsoil characteristics and the contaminant testing we conduct, and utilizing kind of a flowchart approach where we assess the existing soil quality to determine what treatment we'll go with. Here's just kind of a draft list of parameters where if the existing soil was outside some of these parameters, we might consider replacing instead of reusing. But this was also provided by Vinelad, but it's something kind of a living document that we can modify as we learn more about these relationships. So with all that in mind, I'll speak to York Region practices, what we've been up to with this information. So just to throw some numbers at you, since 2017, we've installed about 10,000 square meters of soil trenches on our roadsides. In the years leading up to the Vinelad partnership, it was all EGM trenches, but in 2019, we had that first trial set up. So just a small component was this organic amendment trial, and in subsequent years the following. But in 2021 and this year, we've kind of upped that ratio. We're doing more of the organic matter amendment trial. We don't currently have a lot of data and monitoring to compare the results of these treatments. So we're not going all in on it quite yet. But the idea would be that if we do see good results, we can institute a broader implementation of this treatment pending, the outcome of successful results. For now, it's more the heavy lifting. This is an example of a site on Major Mackenzie installed this year, where we do excavate to 50 centimeter depth and replace it with our engineered growing medium. It's something over the past few years I've learned to get familiar with and how it all works. It's a bit of a moving target for a few reasons. I'll speak to the new regulations in a moment. But this heavier handed approach where we're replacing all the soil on site does have some downsides, even if it is effective for improving conditions for trees. So first is cost. It's not expensive. It's not cheap to do this. And we've only tendered the amendment treatment once, but right away, it's pretty clear that the amendment treatment is significantly lower cost to install than a full soil replacement. The other issue that I've learned to deal with in the past year is the changing excess soil handling rules with the institution of the new regulations, and the fact that it's wasteful to be moving and all this soil around if it can be reused on site, if we can just amend it and have similar results. And then I also speak to the quality control of the mixed material, which is another kind of ongoing issue whenever you're ordering soil mixes to be delivered to site. So the new regulations, Nicole already spoke to, what they're intended to promote the beneficial reuse of soil on sites and prevent good soil from showing up at landfill sites or contaminated soil showing up in places where it wouldn't. So it's a well-intended and much needed regulation. So that's a good thing. The challenges it presents is that if you are involved in projects where you're handling excess soil, your life got significantly more complicated. And I've kind of learned that firsthand as I've done my best to understand and implement and be compliant with the new rules. One of the big changes is that who's ever, conducting the project takes the role of the project leader. I'm not allowed to kind of delegate away the liability of the soil handling onto contractors anymore. Not that that was our approach or practice, but it is kind of the legal responsibility is on the project leader to do that soil planning and have a soil management plan and make sure that the excess soil handling is done in accordance with the new rules. What this means for me, because I'm not an expert on soil contamination and testing and reuse sites, and it's also required that a qualified person under the Act, and that's a professional engineer or geoscientist, has to prepare a lot of this work for you. That includes the soil characterization report, a soil management plan, and in our case, because we are moving relatively smaller volumes, interpretation of the rules to justify us being exempt from the provincial registry. And then as a final component, tracking sheets and record keeping of where all the soil is moving to, what sites are receiving it. And I believe I'm required to keep all this documentation for 5 or 7 years or something like that. So at the end of the day, it represents additional costs, complexities, and obligations and risks for projects that deal with excess soil. And in my mind, it's good incentive to figure out ways to work with existing soil. And that speaks to what Nicole was mentioning. I guess that was largely the intent of this legislation in many ways. So I'm hopeful that the amendment trial that we've been experimenting with proves to be successful so we can avoid projects where we're dealing with a lot of excess soil handling. I'll skip through this. This is just stuff my QP had prepared for me. And then another big issue with the EGM trial trenches when we're having large quantities of soil mixes delivered to sites is quality control issues. In practice, it's difficult to determine if the materials being delivered to sites are exactly what you've ordered. You can write up as precise specifications as you'd like, but at the end of the day, you have trucks and trucks of soil mix showing up, and it's there's a lot of room for error. And even if you're testing the sites, there's delay in lab results. If it takes a week to get test results back, the construction could be complete by that time. And repairing deficiencies with soil mixes is not easy or cheap to do. So it leaves the room open for a lot of headaches, a lot of conflict, and some expensive mistakes. And in our experience, it's difficult to monitor all the material that's showing up at site, and there are mistakes and deficiencies occurring from time to time. This is 1 year where test results showed up pretty good. The mix was largely what we wanted, what we were asking for. So happy to avoid conflict there. And another year where it was a bit all over the place. We had one mix that was almost way too high in sand, and then another mix where the clay content was way higher than we wanted and contrary to our approach with EGM. So this led to some pretty uncomfortable conversations and expensive deficiencies to repair. And it's been a bit improved lately, but it does feel like a bit of a cat and mouse game when you're having soil mixes delivered to site, just staying on top of the quality control. So it's just, when you're introducing new material to the site, it's just another kind of headache you have to deal with. So just to wrap things up, York Region is currently utilizing 2 different soil trenching treatments. There are definite downsides to full soil replacement treatments. So it would be ideal to have an effective soil boulevard soil amendment treatment to kind of mitigate some of these downsides while not compromising on the benefits of doing some soil treatment on our boulevard soils. And the next steps will just be to monitor the tree establishment and growth and adapt our practices accordingly. And that's all I have to say. And I think ready for questions. So thanks for your time. And that's all.
Okay, it looks like we had a few questions on the chat. Going back to the beginning, Megan had a question for Nicole about what type of soil amendments would you use to make the soil suitable for planting?
It's a little bit more complicated than just saying one. My question normally back to people when we start to amend is, what did your soil test results come back as to begin with? We have a lot of different ingredients that we can put together in order to make that organic matter component in order to change the soil. I saw in Gilles' comment that he had posted up in the chat, it's very difficult to change organic matter content. It is. And sometimes in order to get a serious change, we are adding quite a lot of organic amendment in order to do that. And I am choosing very specific organic matters in order to make it happen. So my answer is not necessarily a good one. There are a lot of different things that are available to us. We have our standard amendments if people don't want to go to the length of having a soil test done. But if we are working in situ, my answer always is get a soil test done and know where you start, so that we can either put together the proper mix or figure out what to do with exactly what you have. And yes, a microbiology should be done too, if you can actually afford to have it done.
If you wanted to scale that right down to just the home garden, and you were up against going to the nursery and buying bagged soil, could you give us some guidance on what to look for and to add to the soil without tests, say, that were done?
I would always say have a test done, even for the homeowner, because you really don't know what you're starting with. I can tell you to go out and do some of the simple tests we do in the field. You know, if you're doing a streak test between your fingers to see how much sand, silt, and clay is present, we can do a float test to determine rough particle sizes about what sand, silt, and clay would be present. But it never works out the exact way as to see what you've got coming out of the lab. In terms of, you know, like people look at soil tests actually normally in the wrong way of saying sand, silt, and clay content, because when you're reading a soil test report and it says sand, silt, and clay, you're not actually talking about necessarily sand particles or silt particles or clay particles. You are talking about the particle sizes of all of the things in that mineral component of the mix, or even in the organic matter that rate between those sizes that I had put up in my chart. So depending upon the level of degradation of the organic matter that we can put in, if we do a topsoil report on it, it can rate as sand, silt, or clay, depending upon how far the degradation is. So a soil test report gives me the breakdown of how the particles fit together, not necessarily the components that are actually part of it. Do I add sand, like actually sand to a mix, or will I actually add clay to a mix? Yes, depending upon what I am looking as the final results and what I'm starting with.
Okay. Did anyone have a question to add to that? Okay. Another question is, yes, there will be a link. Gills, you had two questions. Nicole, did you respond to that first question already?
Well, I had seen Gilles' first question about the 4% organic matter. One of the big things I do think everybody forgets about organic matter is amazing. It is, like I said before, it is liquid gold. We cannot ever forego that. That's what creates the life of our soil. But because it is the life of the soil, the plants use it. So by adding in 4% organic matter, or by hoping to increase the organic matter of a soil to 4%, we also need to be taking into account what plants are you putting in and what are they going to use. So, you know, like it is a fine balance between trying to figure out what, you know, are the leaves going to be left in place? How much natural root death is going to be occurring? What other processes are going to be going on to replace that organic matter that's going to be used? It's one of the biggest problems we have in modern agriculture is that we clean the fields. There is nothing left. There's no cover crop. There's nothing to actually go back except for the manure that might be added back onto the field after it's done. That manure doesn't even replace what the plants for that year used, let alone to actually bring it back up to where it was.
I'd like to put this out to the group again, just as a home. I provide home gardeners service, and when they say, "Oh, I need to get some mulch," I always have a little discussion with them, saying, "If you are spending money, I would rather you put compost down than mulch, and we'll time the mulch later in the season by using the leaves." And I'm just wondering if that's sage advice or not.
It depends on the kind of mulch. And it depends on the kind of compost that you would be putting down. So,
well, I'm usually up against what's sold in the garden centers. So I try to go for the highest organic content of the bag and try to use reputable companies.
Yeah, so the only thing you have to watch with the manure, most of the time what's coming in a bag is either peat loam, and a lot of other people will refer to peat loam as black peat. So peat loam is not peat moss compared to what people think coming out of a bog. Peat loam is actually the material that comes, it is all of the degraded marsh material out of the bottom of a fen normally. So you are dealing with a very high level of decomposition, and as soon as it comes up into air, it degrades. So that's what people are using as peat seds or peat loam when you see the top dress mixes that people want to put onto their lawn. What everybody always wants is a short-term effective peat loam because it has a very, very high carbon content that will actually increase and beef up the soil. It lasts at tops a year. If you are going for a manure, you need normally to get into an organic content, if like an organic certified, if you can. If you can't, I would try to stay away from the poultry manures, chicken, or geese I've seen in the last little bit, because they are too high of pH and will burn if you have smaller plants going in. You can use sheep manure, cow manure blended together are fine. Duck we've had quite a lot of good luck with because it normally includes bedding. If you're going to be adding that in, I would add that in and then mulch, but I would depend heavily on what kind of mulch you were putting down.
Pine?
Pine is great. Cedar is great. I would stick away from dyed. We do use a lot of dyed material in here, like at Growbark, we make a lot of dyed mulches. All of our mulches are charcoal based, so they are environmental and they are not organic certified, but as close as we can get to that. And when we are making our dyed mulches, we are not using recycled wood. We are using wood that comes from offcuts of the mills, that instead of all of that bark and whitewood material going into the landfill, that's what we actually turn into our mulches. If you are looking for something very organic and natural based, I would be getting into more of one of our composted or an age bulk or our age mulches, sorry, that will only last for a couple of years, and they will actually degrade down into that top level of your O layer.
Okay, thank you. There's the last two questions in the chat are also probably directed to you as well. Make a mix that's based on what the plants would be growing at that location. What facts about the plants would you use to inform what is needed?
Water requirements, especially. You know, I mean, I can't name the amount of times that, and I deal with a lot of rooftop projects as well with green roofs, and I can't name the amount of times that somebody has said, I'm going to put into a sandy soil and plant in hydrangeas. Well, hydrangeas are a water hog. So if you are putting hydrangeas into that scenario, they're going to heavily suffer. So I work backwards a lot of time and will say to somebody, what kind of plant material do you want to put in? What kind of drought and stress tolerances will they like? And then we can work backwards with the soil. So, you know, what you have to try to do is just literally watch what the requirements, especially when related to water, of what the plant species are, in addition to their light content.
Okay. Then there was a quick question about soil testing for projects that don't have a budget or a timeline for lab testing. Is there another way you recommend to test soil?
I take a really good look at what plants are already there, how they're doing. And normally I dig a giant hole to see exactly what situation I've got to begin with. And I have been known to pull out a hose and fill the hole up with water and see how it drains.
Mm-hmm.
I'll just add to that really quickly. So there's a resource that's available through Landscape Ontario, the Ontario Landscape Tree Planting Guide. And there are some useful tips and tricks in there as well for, ad hoc soil testing that you can do in the field, whether it's testing compaction just with a prong or, looking at the textures, like Nicole said, to start to visualize and understand what material you're dealing with and how you can proceed in terms of planning and planting effectively.
I guess I had a question for you, Charlene. When you showed that slide about the highway roadside planting trial, what month was that taken?
Those
with all the trees.
Those specific photos were probably taken late summer, early fall. That's typically when we would go out and evaluate the trees.
Okay. And then when you have those 36 planting boxes,
yes,
are they planted with all the same trees?
No. So currently that experiment has 2 species of trees and then 4 different soil mixtures. So like Nicole was talking about, we've mixed we've selected one soil texture, but we have different mixtures of organic amendments in those soil compartments to help us understand how they behave under different watering and watering conditions for the most part.
And which trees did you choose and why?
So for that trial, we have selected Acer Fremani. It's one that we work with a lot of the time. Right. Mm-hmm. And then we also have tulip trees in there. And so for that trial specifically, we're hoping to select species that are representative of the species that our municipal partner would plant. Right. So they want to understand not just the low impact development applications of this soil, but then also, how do some of our most commonly planting species do in these soil mixtures as well. So those species were selected because they're representative of what a lot of municipalities are planting, but they're also representative, like Nicole said, of different water requirements and pH requirements and light requirements. So they capture or give us a range of understanding of how trees might perform in these soil mixtures.
When would you like us to remind you about it, more information about the webinar?
Oh, I can do that right now. So I'm just going to share my screen one more time, actually, because I have a QR code that you can use to find the link to register and all of that. So just one moment. There you are. So this webinar is part of our Greening the Landscape Consortium. And we get together twice a year to have what we call a conversation about a different topic that is chosen and selected by our members. And so this November, we'll be having a conversation about the new growing medium section of the Canadian Landscape Standard, which, like I said, is, I believe, scheduled to be released earlier next year. But it's something that, we've collaborated on. Nicole has provided so much valuable information and insight toward the development of that. And we're really, really pleased with it. And we're hoping that it can be more useful in the field for practitioners, landscape contractors, anybody who would need to have some reference material and some evidence-based reference material for growing medium in the landscape. So if you go to that QR code, there's a page where you can register, and yeah, feel free to share with anyone that you think might be interested.
Thank you.
No problem.
Karen had a question that says, seeing that these trees are along roadsides, I guess this is to Mike, how is it that road salt spray factored into your findings?
Well, it's just kind of a fact of life on the site conditions. There's going to be a lot of road salt both in the soil and sprayed on the trees. Region roadways are typically high speed, high volume major roadways. So it's reflected in a lot of the contaminant testing. We don't find a lot of contaminants in our soil, but electrical conductivity and sodium absorption ratio is usually exceeding a table limit or two because there is a lot of salt in the soil. So in practice, it's more species selection. We don't plant non-salt tolerant trees directly next to the roadside. And that's sort of the best we can do with the sites.
Okay, and Jill's had another question. This is an interesting one. When we talk about using existing soil, it refers to keeping the indigenous microbes in place. Is there a microbiology section to do the tests? I guess you're asking, can you test the microbes in the soil?
You can. Oh, sorry, Charlene, did you want to go?
No, you go ahead, Nicole, and I'll see if I have anything to add.
I was just going to say there is not very many labs who test the microbes and test them well. And most people who test the microbes don't even know how to read the soil test results. So it's one of those things we here at Growbark and at Walker, we normally reserve our microbe tests for compost runs when we're trying to make sure that there is active life and depending upon what stage the compost is at. We have tested very specific lid projects to make sure that we were adding in the right amount of material, but knowing what levels all of the decomposition is at, especially in our leaf and yard waste compost, we know exactly what microbes are going to be there depending upon the stage of the decomp.
And I'll just add to that very quickly. So one thing that our lab does here at Vinelad, in addition to the research projects that we do, is we do offer soil testing services. And one thing that we've recently incorporated into our soil tests to sort of round out the biological side of our testing is a soil respiration test. And we found that it is a pretty high level, but quick and effective way to get a sense of how much life you might have in your soil based on the respiration of those microbes and characterizing, the quantity of respiration that we see. And so that's one way that we've started to do it. But like Nicole said, they're often quite costly and quite difficult to access. And so it's something that we're hoping can start to become more accessible in the future.
Charlene, would you mind going through what we would do if we wanted to send you a soil sample and the cost of it and the turnaround time?
So at the moment, it would be contacting someone like myself or one of my colleagues through Vinelad just to give us a sense of what your project would be and how many samples you'd be looking to submit. But yeah, we do offer a soil analysis, like I said, through a soil health approach. So we analyze physical, chemical, biological, and hydrological characteristics, and it really does depend on what you're looking to get out of your analysis. So we have different packages. We have a base, a moderate, a more comprehensive package. So understanding the cost and exactly what you would get would really depend on your project and what you were looking to understand about the soil. But feel free to reach out to myself. I can share my contact information. If you wanted more information about that, I'd be happy to share some resources.
Okay, so the turnaround time would vary.
It would, depending on what you were getting. For our base package, the turnaround is 2 weeks.
Okay.
Yeah.
All right. And so back to the questions, let's see. Okay, Matt has used Growbark live mulch products to amend existing soils with good success. That's a comment, which I have to agree with. Oh yeah, and another question to add to the soil testing question. There's mixed reviews about the small kits. I guess we wanted to have your opinion on them. The soil testing kits.
Nicole, I see you smiling. Do you have anything to?
Well, I think it all depends on the tester. And it depends really on where you sample. Like when Charlene and I are doing a test, we're looking for a test, we're doing what people would call like normally a comprehensive or a, I don't even know, I'm totally blanking on the word right now, but we will take samples from 5 to 6 different areas and blend it into one solid sample, and then that's where it's coming from. So it is essentially an average sample from multiple locations. If you are not taking a big enough sample and you're putting this much soil into, a little testing jar, it's really not very accurate. That's all I would go so far as to say.
Okay, and just to keep on the soil regulation, Jessica just wanted to add something. She was told that it's best to plant trees with native soil without any amendments. Just wondering what any of your thoughts on that are. So just plant with what you've got.
Charlene, do you want to go first? You know what I'm going to say. My question is going to be, what's native soil?
Yes, because I think a lot of the time in urban settings, what you find is native soil is a lot of fill. And I think Nicole showed a photo at the beginning of her presentation that is representative of, I guess, what we find as native soil in urban settings, which generally is not particularly suited to tree growth or productivity. Nicole, I'll hand it over to you.
No, I would just add to that I have been doing this for a long time. I'm not going to give out my age, but I would say at every single site that I've been at, probably for the last almost 30 years, there is not what I would consider to be true native soil. I mean, and native soil is what? Pre-people, pre-residences, I'd like a little bit of, add to that. But I would add to what Gilles had typed in the chat before about it might not be quote unquote native soil, but it is soil that has become more nativized by being in that area. So you already have microbiology that's living in there. For me, that is better than bringing in something that has not existed there. So I would rather take what is already there as long as it is workable and use that as native soil than bringing in something else.
And
I think that's probably what she was referring to.
Yeah.
And oftentimes with tree planting, you hear about the bathtub effect and people planting holes and then adding an amended soil and having a contrast in texture in a small area, and then that can create drainage problems that aren't worth the attempt to kind of improve the soil on that small scale, because it doesn't really benefit anything.
Here's a fairly large question, which is intriguing. I'm not familiar with the excess soil regulations since I normally work with homeowners, but I've just taken on a project with a developer. Do you have suggestions for designers who want to broach the conversation about reuse and amendment of existing soils with the developer? I'm assuming you can request soil management plan for data about the characteristics of the existing soil. Is that right?
Based on the new soil regulations, they will have to do that. Now, that is not going to be set in stone until next year, but depending upon when the project is going to go, they will have to have a soil management plan for the entire property.
Right. So is it going to? No, I won't even ask.
It's something that they're going to need to start well in advance and to figure out how they're going to handle the entire subdivision.
If you're just not talking about a subdivision, if you're just talking about a 10 by 10 area, say, for example, and you need to remove the soil, is that still going to be feasible?
Technically, no. You know, like if you're going to be one of the people with a truck pulling up to the road somewhere and dropping off the soil in that space, but they're getting very, very strict on it, you know, in terms of having even the truck drivers or whoever's in the truck has to have the appropriate paperwork with them, showing exactly where it came from and all the testing from the soil of where it came from.
Cool.
So I have a question to add to that, if I may then. Let's say I'm putting in a patio in the backyard, and what I've done now, obviously I can't use all that soil on site in a small downtown yard. I need to take it somewhere. And I'm taking it to a transfer station in the city. Now I dump it there. Is it up to them?
It will be, yes.
Yeah.
So it will be up to them as to whether they accept it or not.
Okay.
And they will you will be ultimately responsible for it. But it will be up to them to ask you what the testing is on the material that you're bringing in to show that it's not contaminated. And if it's essentially contaminated, there are ways, I mean, like I said before, the legislation is huge. Like we have one person on staff that's all that they handle is that excess soil regulation. But essentially it's up to them about whether they take it or not. Contaminated soils are one of the allowances that can go into a landfill. If there is nothing wrong with the soil, they have the right to say, no, they won't take it.
So that sounds like I need to do a soil test every time I take out half a yard of soil out of a project.
Unless you can find someone who will take it, yes.
Okay.
Is there a gold standard for the testing center?
About location of where to get the testing done?
Yeah.
Well, Vinelad to start off with.
Right.
But if you're not going to Vinelad,
Yeah,
then I
yeah.
would go to SGS.
And we do the same. We typically go to SGS. They have some really great basic packages that are pretty affordable, and their turnaround is great. So.
And so if these regulations are going to come in, I mean, they're already in, but if it starts, you said next year is when it's really going to be.
They came into effect January 1st of this year, but they did roll back some of the sections on testing and parameters. I think, don't quote me on it, I think it was until June 2023. Mike, do you know the exact date?
I think it's based on the information I had, I thought it was the beginning of 2023, unless
But
it was again.
sorry, I didn't. But essentially what they did is said, we need some more information to make sure that we know that people are looking at these testing numbers the right way and that people know how to read it and know how to test for it. So they rolled it back and said, we'll give you another year grace period. So what was supposed to be a couple of year rollout looks like it's now going to be about a 3 or 4 year rollout by the time they get everything in.
Because I can see a backlog now if I'm having to send a test in, because I'm in a different garden every week. If I'm sending all of a sudden 40 tests myself in the season, and the next landscaper's doing the same thing, are we going to have? This is, well, I'm not sure you can answer that. Are we? Yeah, are we going to be able to have that infrastructure in place so that tests can have a positive turnaround time?
I know they have discussed it at the lab level. As soon as the legislation came out, they were talking about how to increase lab capacities to be able to handle it. As it is right now, I mean, we send on average somewhere between 15 to 20 tests to the lab a week, and we can wait 2 weeks now, let alone add in the new legislation when we're in the middle of season. So you're right, there could be a bottleneck from it.
Do you want to share the information for SGS? Or is it just look it up on the web? Is it easy enough to find for?
The SGS lab that's the closest one to us that does the majority of the topsoil reports is in Guelph. I can send it to you after the fact with the links to the even basic topsoil testing page.
Great. David, you want to help me out? Did I get to all the questions?
I think Megan has another question here, or did we add? It says, when amending soil with organic matter at the time of tree planting? The example, the Vinelad experiment, looking at highway adjacent trees, would that amendment be just in the planting hole or the individual tree or a wider area?
So that would have been across a wider area, similar to what you saw in New York region in terms of planting trenches. So it's not just the planting hole, sort of a designated trench area where the trees are going to get planted and the whole area is deep ripped and amended.
I had a question, I guess. I've always wondered about soil that is coming from yard waste. Oftentimes you find there's environmental days in neighborhoods and they dump a load of soil there for neighbors to come by and pick it up. And I've gone through some of that soil. You always find plastics in there, and maybe I have it in my own compost in the backyard when maybe you put a banana peel and still has a sticker on there. There's lots of those fruit stickers and things in the soil. Look, I wonder, what's the testing, or do you guys know what the testing is on that compost that they're always
There are two
producing?
different kinds of compost. You have what's called SSO compost, or source separated organics. So like for us here at Growbark, the Growbark Caledon location, we only make leaf and yard waste compost. So it comes out of all of the municipalities for their leaf and yard waste program. So we don't take any kitchen waste into this program because of the EC or salts. So kitchen waste material is much higher in salts than leaf and yard waste. You are right, there is always, contrary to what people think should be coming out of compost, there is always contamination in compost. We do have bets made about what is the craziest thing that we're going to find in the compost bag or in the leaf and yard waste bags this year. And I'm not even going to get into some of the things that we have found, including full tricycles and cases of beer bottles or whatever. We are well under the allowable limit of what is considered as contaminants in compost for what is allowed. Our compost leaf and yard is organic certified. It completes the Canadian organic regulation, but plastics are one of our #1 issue, because when all of the leaf and yard waste comes into the facility, it actually goes through a full grinding machine. So if somebody has thrown a bag of dog, like dog poop from taking their dog for a walk in a plastic bag into it, it will get shredded to 1,000 times 10 and goes right through the composting process. So we have full metal magnets on everything. We pull out obviously as much as we can, but there will always be something in there. And the only way that we can get it out is for people to not put it in.
Sounds like a billboard's needed.
Oh, are you kidding? The amount of municipalities we've gone to on those days when we drop off compost and say, come and fill up your buckets and take this home for your garden. Normally we have a full table set up about what should and what should not go into your compost. But I think we could probably be talking forever about that to educate every next generation to make sure they know what happens and how does it get processed and what things are our nemesis, like glass. Glass is one of the worst ones. All it takes is one beer bottle to go through the process and it is in 1,000 little pieces and we can never get it out.
Okay, Jessica had a follow-up question about the tree planting. Could you clarify the reasoning behind trench backfill amendment method at highway roadside shown in the presentation? And what would the long-term impact be on tree growth, assuming that the roots go deeper than the trench depths?
Absolutely. So the reason that we do the soil remediation in trenches or in areas larger than just the planting hole is exactly sort of what you're alluding to. It's the idea that the roots are going to grow and that they're going to expand beyond that immediate planting hole, and that we don't want them to, as they're growing and being productive from this amendment or this improved soil, to then hit dead space or to hit, really compacted, unamended soil, and then lose all of that access to resource and water and nutrients. The trenches themselves, like I said, they're deep ripped. So the idea is that you are decompacting and that you are amending to a depth where, a lot of your roots would be extending downward. But a lot of the time we find that roots actually do a lot of lateral expansion. There are some species that are tap roots that will go straight down, but a lot of the ones that we're planting, you know, they're extending laterally, and that's why we go with the trenches as opposed to just amending the planting hole. Hopefully that answers your question, but feel free to let me know if there's anything else I can clarify.
It's also really good to add to what you said, Charlene, it's also really good to have the trenches, because especially if we're thinking about the salt aspect, salt typically for what the municipalities use and on highways is sodium chloride. It's not so much the sodium that we are necessarily worrying about, because as long as it has been trenched, it can flow through the system. It's the chloride that's the issue, because it sticks to the soil particles. So if we have a wider area, it helps to mitigate better the effects of the salt that's coming off the road.
I wonder if this is a good time to just let people open up their mics and ask questions freely. You're invited to unmute.
Yeah, I'm okay with that.
Mm-hmm.
I'm just wondering if you could define what deep ripped actually is. Like how deep are we talking, and what is the ripped part? I'm a little confused.
Yes.
That terminology is all.
Yep. So it's, and Nicole, I might ask for your help here because I'm blanking on the depth that it goes to, but it's basically like a prong or a tine that's attached to, not great with machinery, but it's basically, Nicole, can you help me?
It's just almost like on the back of almost like you were on an agricultural field, and it's one of the times that instead of the spinning disc that they use to auger, they're actually using almost forks that prong in and pull through. So they're creating an open air and water space that can't instantly come back. You are creating a structural component to something that didn't have it before. So I have seen a multitude of depths used, but a lot of times they are using those depths down somewhere almost to 3 feet down, if not deeper.
Thanks. That's kind of how I imagined it. Thank you.
I have a question. Can you guys hear me okay?
Totally good.
Hi, Jetta.
Hi.
Hi.
This has been so awesome. Thank you guys so much. I work with a lot of containers. I know that that's maybe not the same jurisdiction, but do you have any ideas for container soil mixes or amendments? Or I've been looking through the Grow Bark products, maybe something that if I added something like extra perlite to, I can make it work. Just whatever you guys think.
That's a whole other kettle of fish. I mean, the catch with it, you think about, you want to take the environment and plunk it into a container, right? And the biggest problem that we have with containers is you are in limited capacity. The shape of the container totally determines how the water flows through, in addition to what you've got in the container and your plant. So, and how long it's going to be in that container. So there are like 5 different things we're all taking into account, trying, actually way more than 5, how it's going to grow. The biggest problem that we deal with is those porosities. So if you're dealing with media that's in a pot, as it's degrading, not only is it shrinking, but it's shrinking down to the bottom of the pot. So you end up with what we get is what we call a lot of fine material. So what would be considered as clay content if we were out in the field, that sits at the bottom and doesn't let a pot drain. So when we're dealing with container growers in the nurseries, we are looking at how long is that plant going to be in there? How much degradation are we going to get? How are they watering? How are they doing at home? What I would say is just make sure that you're not, say, putting something in that's straight peat moss or something along those lines, because not only will it not last, it won't hold water and you won't get a lot of natural nutrients from it. So a lot of that, you want something that has compost in it, you know, that will give you that soil life, but you also need something that has bigger particles to it that it won't fall apart on you. So trying to find a decent potting soil that isn't 80% peat moss would be where I would put it. Perlite really is a waste.
Yeah.
Oh, did I just open a huge other can of worms? Okay, so perlite is essentially, if you, Charlene's laughing at me already. We're not going to talk about this for an hour.
I'll call you
Perlite,
later. We'll talk about it.
we'll talk after. Perlite is essentially a popped rock.
Mhm.
So if you take, they call it slag. You take slag out of a quarry and they put it in a huge kiln and they pop it like popcorn. What's it going to do? All that perlite is in the pot is a water hole, like is an air holding spot. It prevents the soil particles from collapsing on itself. That is it. It provides no nutrients. It does not hold water. There is nothing about it other than preventing the mix from collapsing. There are tons of other things that we can use instead of perlite.
Like?
We can use coarser sized pieces of bark that will actually add microbial sites on for long-term life. There is reclaimed brick and reclaimed clay pieces that will actually provide and break down for natural nutrients. So there's a lot of other things on my side of the world that we can use. If you are a homeowner looking for that, is it going to be easy to find that? No, but you can get creative and make your own mixes.
Could I like repurpose from a project? Let's say if I was ripping out brick, could I use that in
100%.
a container?
As
Cool.
long as you know what kind of grouting or what kind of mortar is between all of the brick material. So we use a lot of reclaimed pieces on our green roof site when we're making the mixes. All of our bricking material comes from the brick industry as their waste. So we actually take their bricks and grind it down to sizes to use in all of our mixes.
That's awesome.
So if you want more information, call me after.
Yeah.
Okay.
Yeah, Shada, in pots that I have in my own yard, I just kind of use some of the soil in my yard. I mix it with some potting soil, and I actually tend to, if it's a big pot, I tend to put mulch on the bottom of it, maybe 2-3 inches of mulch, just to kind of, so you're not doesn't make the pot so heavy as well. And I mean, as the roots grow down, I'm hoping that, you know, that bark is gonna, it's good for water filtration, as well as, you know, it'll break down at the same time and provide nutrients. I'm hoping, anyways. But my pots seem to be doing pretty well. So
Yeah, I've been doing this summer, especially for all my commercial projects. It's just been like a container soil, worm castings. I love worm castings, fungi, and a mulch of some sort, like a horticultural grade mulch, usually as a top dress, and almost to line the sides a little bit to create like a little bit of insulation. I've had a lot of success with that, but I've never been to the Growbark website, and all the soil sound so fantastic. So I'm like, what can I put for next year, you know?
I had a question about ball and burlap when we're planting those field grown trees, and it's just pure, like I think it's pure clay. And you're just in an urban environment again. Should you just backfill with what's on site and forget about anything else? Because that material, that root ball is so different from any soil that's on site.
yeah.
In the regions planting, it's just kind of, the contractors supplying trees, we'll pre-tag them in nurseries, but sometimes if the texture of the soil and the root ball differs from the soil on site, there's not much you can do about it at the time of planting. So you just have to go ahead and plant it.
Just use your best judgment.
Mm-hmm.
Like, should you put a heavier clay soil beside it? Rather than a nice, rich, loose compost?
I wouldn't put a straight compost. I would mix it partially with the soil that exists in there.
Yeah, that's what I always do, but I'm just wondering if I should not even do that. Just add, just like somebody asked earlier too, just use what's on site and forget about adding anything to a big heavy root ball like that.
You're talking about cedars, Laurie?
So many of the large wire basket.
Yeah.
You would,
Question, like, I hate planting cedars, so like, somebody asked me to do it, because it's just so difficult to keep them alive. And then I noticed too, once they get beyond that root ball that they came in, they hit that, if it's around here, if it's like a high, leaf mulch soil, they kind of go into a shock too, I've seen.
Mhm.
So they're stressing out because of the change in that, but that's a good question.
Mhm.
Well, let me ask David Milne. We had a conversation. You say you don't like to bring in any soils if you can help it into your sites, into your project. So what do you do?
My big thing is I always add mycorrhizae. Use a product called Root Rescue, but I definitely try never to bring in soil. And I also like to mulch after planting, and maybe a little compost on top. That seems to work for me.
Okay. Does anybody know what's going on with peat moss? I've heard a number of things that maybe peat moss will no longer be available
Where,
At-
here?
at some point, maybe?
It's coming. It is banned in the UK right now. Primarily because the UK and a good chunk of Europe not only uses peat moss for the entire horticultural industry, but also as fuel for heating their homes.
And for their scotch.
Oh, yes. I'm Scottish, so I can relate to that. It came down because essentially they're destroying, there's very large differences between what's happening in Europe and what's happening here in terms of the peat industry. Having said that, we do have a tendency to follow what Europe does. And I know that the bans are coming over. A lot of the products that we have now switched to peat free. So we're in the middle of a lot of growers. We're also switching them off peat moss right now so that we don't deal with any more of our peat bogs here unless we absolutely have to. The bigger problem with the bogs that we have here is that global warming has essentially prevented them from harvesting on the bogs. So what we normally harvest here, they have been able for the last 2 years to only harvest about 60% of what they normally harvest. So I guess nature is affecting it without us bringing in a full peat ban. It could be that way in a couple of years that they're not able to get onto the bog at all. So we know it's coming, and a lot of the greenhouses that we deal with, we have warned them that they are going to have to be willing to turn over a new leaf per se, and figure out how to learn to regrow in something other than peat moss, because we know it is coming.
Nikki, can I just ask, good to see you.
Paul.
Hello, this has been amazing. Thank you to all of you who've contributed, and thank you for Ello for organizing this. This is great discussion. Great to see the investment and understanding the importance of soil. So quick question, you're saying using more peat-free products.
Yes.
So without revealing any top secret things, what is an alternative to peat?
But it depends what they're growing. So
Okay.
a lot of nursery growers are using, okay, back to the soil structure that I had talked about before. A lot of nursery growers are using peat because it is a fine particle to fill in the holes and aid to water retention in their mixes.
Right.
We can use other things in addition, like we don't have to use peat for that. We can use compost for that because it holds 10, or another organic matter, it holds 10 times its weight. Greenhouse industry is a whole other kettle of fish.
Yes.
Having said that, there are a lot of products that we use, especially wood fiber products, which are a recycled xylem material coming out of the furniture industry that essentially act like a straw in the material. So in comparison to, say, cocoa fiber, which a lot of people like to grow in, cocoa fiber is really good at absorbing the material, at absorbing, oh my gosh, water, but it doesn't like to release it. Wood fiber will actually wick it from side to side in the pot. So we've been doing for years now a lot of trials where instead of what a grower would use at 100% peat, say, we have been able to make the mixes work heavily with 50% peat, 50% wood fiber. So we've been able to actually decrease the fiber, like the peat oh my gosh, Nikki, the peat content
Right.
down to 50%. So if we can get a lot of people to do that, but they have to treat the mixes differently. They have to relearn how to water. They have to relearn how to fertilize. Everything is different in that kind of a world. That is completely the way that Europe has gone. So most of their mixes in Europe right now have a minimum of a 30% wood fiber content, if not higher. The biggest difference for us is we don't have the same tree species that are available to use. So we've been dealing with a lot of other, other tree fibers that we can get to see how they actually handle. So it's been very positive. Knock on wood, it keeps going. So
that's awesome. Thank you.
Yeah.
But my original question was, I'm hearing all this discussion about the importance of organic matter, absolutely amazing, and it disappearing. Is there any work or any research that's being done, whether it be on the roadways? We put down a mulch. We've added organic matter, or we put down a mulch. Is there any work being done about using a living mulch that's going to constantly be adding organic matter, as opposed to using something that we have spread that's shredded?
Oh, as a true mulch?
Yeah.
That would be where our live mulch comes in.
Okay.
So, and I know that's a proprietary product for Growbark. I understand that, but that is our live mulch, and it's called that because we are blending compost with all of the microbes in it with a bark that's going to be used as a mulch. So we add in different grades of coarseness of composted age barks into those mixes so that there is long-term fodder and food stock for the microbes that are there.
Can I add to that?
Go for it, Matt.
We use that product on a 4,000 square foot planting in Caledon. It went in 3 years ago. 60 cubic yards, I think we put in, and we just cut out the existing weeds and crap that were in this large garden space. And then 60 yards of that live mulch went in. And if you look on my Instagram account right now, I took some photographs this afternoon of the planting that was done last season, and then some planting was done this season. And the results are pretty good for like a naturalistic meadow style planting with lots of native grasses and things. It's a good product, I would say.
So to switch, even from that, a lot of, I deal with a lot of the cut flower industry as well, who grow under glass. Mm-hmm. And if they are growing in bed, Paul, you would know about a bunch of the people if I start listing them off, and I can tell you on the side if you want to know, but when they are growing in ground, they are dealing with whatever soil they have present in the houses. They normally have a fair decent amount of compaction that they have to get rid of that as well. One of the cut flower growers, we installed 8 inches of our live mulch in their houses 8 years ago, and we have never topped up. And when we do soil test reports, the biology comes back off the charts. Their organic matter content right now of the 10 main houses is sitting at 18%. Oh. And they steam every third cycle of cut. So shows you how much, and I'm not trying to, but there was a lot of research that went into that live mulch to make it work right, and the percentages that we wanted together. We know that it does work. So blending that kind of stuff has a really good effect. So I know we are unfortunately one of the only ones, and I have talked until I'm blue in the face because not everybody believes in that regimen, but we heavily do. So
very encouraging. Thank you. That's amazing. That's great. Thank you.
Matt, when you used that large volume, did you have anything else mixed with it?
There was this garter snake that crawled out and just about gave the lady a heart attack.
And how's that garter snake doing?
I don't know. She wouldn't have the heart to kill it, but
top to bottom, it was just the live mulch you used.
Yeah.
Mm-hmm.
It was a garden that had been. It was a garden that was planted by the client's father, and he passed away, and they didn't step foot on the property for a number of years after he died. And so it was sort of a restoration project, but they allowed me to have pretty much free reign over how I restored it. I
Nice.
followed some of the existing perennials like over a couple of years. We did a kitchen garden there too, and we used the Grow Bark organic garden market garden soil or whatever it's called. But all we did was mechanically remove the top layer of overgrowth like weeds and junk and a few leftover perennials. And then I added the 60 yards of this live mulch, and we turned it in a little bit, I must admit, and then started planting over the last 2 years. It's worked pretty good.
Well, we're getting on to 6:45.
Mhm.
I'm happy to stay on. Does anybody have any other questions or comments, or have we all got our soil triangle that we're going to paste to our computer screen now? Yeah, it's been very, very scientific and very practical as well at the same time.
This was excellent. Excellent. Thank you very much.
Yes.
Yeah, thank you very much. Should we wrap it up? Anything else?
So thanks to
Yeah.
Charlene,
Well,
Nicole, and Mike. You guys did an
Yeah, absolutely.
incredible
Thank you very much.
presentation.
It's really appreciated. And for everybody who attended, thank you. It makes it worthwhile putting on these presentations.
And it's the enthusiasm that you showed and jumped right on board that makes me think that this is just chapter 1 of a few that we can do in the future. So thank you.
And I think as landscapers and horticulturists, we need to learn more about soil because, it's a profound living organism from my perspective, and we need to understand it much better than we do.
Well, maybe that's a good topic for another discussion, David, when we just break down soil for an hour or so.
An hour, that's not enough time.
Okay, two or three then.
Thank you all.
The